So radiation, radioactivity, there are three main types. The first type is what's called alpha decay. The symbol for alpha decay is that funky little, well, it looks like a little fish like that. It's where we actually get our Greek letter or our English letter A from. And an alpha particle is made up of two neutrons and two protons. These are alpha particles. Back of it, back of it, back of it. Keep going, keep going. Should be at the bottom of the chart. You got it? Okay. We can make alpha particles like crazy. In fact, we use these all over the place. And these are not harmful. These are harmless. Who's got their pink sheet? Got it handy? Look at helium on your pink sheet. Element number what? 2. So how many protons does it have? Element number what? How many protons does it have? 2. What's its mass?
4.
So how many neutrons does it have? It has a total mass of 4, and 2 of the masses are protons. What's left? An alpha particle is a helium nucleus. Because helium also has electrons. We can strip the electrons off of helium pretty easily. We just use a big positive charge to rip the electrons off of the helium atom. And Kenzie, what you have left behind are alpha particles. So an alpha particle is basically a helium nucleus. And Brendan, we write it two different ways. You can either write it as He for helium, or you can use the funky alpha symbol. How many protons did helium have? What did you tell me? Oh, and what was its mass? No, what was its mass? This is how we write isotopes. This is how we write radiation. This is how we write radioactive particles. You can write it as 4He2, mass of 4, it's a helium nucleus, 2 protons. Or if you really want to show that it's not a helium atom, that it's the alpha particle, you can use the funky alpha symbol. Alpha particles, alpha radiation. Okay. Question? Then we also have beta decay. Beta decay. And beta decay is an electron. By the way, the symbol for beta, it's a capital B with a little tail. And yes, alpha, beta is where we get our English word alphabet from. It's literally in Greek the A's and B's, like our ABCs. Some elements give off beta decay, give off electrons. And we write it as follows. We can either use a lowercase letter E, or we can use the beta symbol. I like the beta symbol. What's the mass of an electron? It's a trick question. It's really close to something. That's its charge. Its charge is negative. What's its mass? Basically, it's a mass of 0. So close. You'll notice when I asked you what's its mass and you said 4, I said, well, there's 2 protons, then there's 2 neutrons. I didn't even care about the electrons because they're so close to 0, they don't make really a difference when we're doing the calculations. What's the charge on an electron? That's how we write beta decay. Okay. Electrons can be harmful, can be not. Depends on how we treat them. Beta particles can be good, can be bad. The ones that'll kill you, the ones that are unhealthy, the ones that have killed people over the years are gamma decay. Now, the gamma symbol is written, actually that's not quite right, Mr. Duick. It's written like this. It's sort of like a fish standing on its head. And a gamma radiation Jessica, is not a particle. It's not a physical thing. An electron is a physical thing. An alpha particle is a physical thing. Gamma radiation is pure energy, which is why it does so much damage. Because if it was a physical thing, Emily, we can block it pretty easily. In fact, alpha particles, we can block with a piece of paper. Beta particles, okay, we need to block them with a little bit more. Gamma particles, you need lots and lots and lots of lead shielding. Otherwise, it's going into you, and when it rams into your cells, it damages your DNA, and that's what kills people with radioactive poisoning. Yep. Well, it damages your DNA, and the result of damaging your DNA is, since your cells use your DNA to reproduce, if the DNA is damaged, they're going to reproduce incorrectly, and that's cancer. So it's a secondary effect. But yeah. It's written as, there's the symbol for gamma. How much mass does energy have? It's a trick question. 0. And its charge is 0. Let's look at these in more detail. So here's alpha decay. You'll notice these are on your green sheet, so you don't have to exactly have them memorized, but you want to, Emily, recognize them. And if you're having to look up some of this stuff, you're going to be in trouble. So an alpha particle is identical to a helium nucleus, He. It contains, I already said this, 2 protons, 2 neutrons. So there are some elements, Oscar, that are radioactive, and what they are giving off are alpha particles. There's a little picture. You can see, I tried to show, it's easier in color, yours is black and white, sorry, but I tried to show 2 neutrons, 2 protons, no electrons. It's a helium nucleus. If you're trying to write an equation, the numbers on the right must add up to the numbers on the left. Let me give you an example. If you have some unstable atom and it gives off an alpha particle, what was the mass of an alpha particle? Do you remember? What's the mass of an alpha particle? I'll give you a hint. It's 2 protons and 2 neutrons. 4. It has a mass of 4, which means your new element that's been created because of radioactivity weighs 4 less. Weighs 4 less. Oh, and it has a charge of positive 2, which means the overall charge of your new element is its original charge minus 2. The 2 didn't photocopy properly, it didn't show up. And unfortunately, on the next couple of pages, for some reason, the formatting went all wonky when I hit print, and I didn't catch it. So we're going to have to kind of fudge things a little bit here. It's easier to do with a specific example. So I think for you guys, it's turn the page. Got your pink sheet handy? Someone on your table? Make sure you're sharing it. Here's an example. Radium. What element number is radium? What's its atomic number? It's right in front of you. You can see it in the chart. 88. How many protons does it have? Too slow. What's its atomic number? 88. How many protons does it have? 88. This radium has an atomic mass of 226. It's going to decay, and the way radium decays, Kenzie, is it gives off an alpha particle. You're going to end up with a new element. Now, instead of having 88 protons, if you shoot 2 protons out, Amber, how many protons do you have left? What is element number 86 on your periodic table? Sorry? Radon. That's the new element that's formed. This is how new elements form from radioactive decay. Oh, what was the mass of an alpha particle? 4. So if my original mass was 226, what's my new mass going to be? 4 less. 4 less. Okay? 88 protons. 88 protons. 226. Still 226. Mass is conserved here. So then it says determine the values for A, Z, X, and Y as appropriate. And here's where all of a sudden the formatting went all wonky, and I apologize. This was supposed to be really big and easy for you to visualize. Everything went kind of crazy. So we're going to start out writing this first one. Here is Rn with a mass of 226, and its element 222, mass of 222, and its element 86. So this is radioactive radon. It's going to decay. Arrow. Let me zoom in so you guys can see what I'm writing. Okay. It's going to give off an alpha particle, so I'm going to leave a space. Plus, here is my alpha particle, which has a mass of 4, and it's 2 protons. See it, Brendan? How many protons did the original one have, radon 222? How many protons does it have? You don't need to look it up. It's right in front of you here. 86. How many protons did it shoot out? 2. So how many protons does it have left? 84. The new element is going to have 84 protons. What element is that? Can you look it up? Because it's also its atomic number. This is why I need the pink sheet. What is atomic number 84? Sorry? Symbol? P capital, capital P, lowercase o. It decays into polonium. By the way, if you haven't got the pink sheet out and you're trying to do this from memory, you're silly. What's the mass of this new polonium? What was the original mass that we started out with? 222. What was the mass of the alpha particle? 4. What's left for polonium? 218. Oh, how many neutrons does polonium have in its nucleus? This particular version of polonium, since it has a mass of 218 and it's got 84 protons, the rest of the mass must be from 134 neutrons. I don't believe. Sorry? Sorry? Why is it 218? What was the original amount of mass that we had? 222. How much did we lose in the alpha particle? 4. What's left? Okay. Those are good questions. The next one. Shrink down a little bit. So it's supposed to look like this. Mystery element, I don't know. You know what? I got to look at my notes here and see what this is supposed to turn out to be. I can't even read this writing. Okay. It's going to have a mass of 234. And it's going to have, bear with me for a second, I can't even read this anymore. I recopied this. We're back. Let's try and fix this. So again, ignore the great big printing. You guys got a space right here to write something? Yes, I hope. So here's our next equation. We're going to go with thorium, element number 90, which has a mass of 230. That's going to decay. So thorium-230. And when it decays, it's going to give off an alpha particle, which has a mass of 4 and 2 protons. Yep?
Thorium has 232.
This one is an unstable element. This has a mass of 230, which is why it's unstable and decaying. Good point. It's when the masses are different from the atomic table, that's when they're unstable. Yep.
How do we know what it gives off? I'm just confused there.
We're going to tell you.
Okay.
Yeah. For now.
I'll stand by.
Yep. No, I mean we're going to tell you what it gives off.
No, but how do we know what the alpha particle gets right away? Is it always the same?
Oh, an alpha particle is always 2 protons, two neutrons
Okay.
stuck together. This is always going to be an alpha particle. It's always going to look like that thing there.
Okay.
Yep. Sorry, I misunderstood your question.
That's fine.
Hey, what's the mystery? What does this decay into? What's the mystery element that's formed? Let's see if we can figure this out. Ready? Justine, my angel, how many protons did we have to begin with? 90. How many protons are used up by 2? Yep. So how many protons do I have left for the mystery element? Sarah? What is element number 88? Sorry? Radium? Ra? That's how I can figure out what the element it decays into would be. Oh. How much mass did I have to start out with? Dylan? In this case, 230? Yes? What's the mass of the alpha particle? Okay. Do I need to move you forward? Do you need to move up, kiddo? Or I'll come back to you in a second. Jenny, what's the mass of the alpha particle? 4. What's the mass of this have to be? Is that better? A little? Sorry? 226. What's the normal mass of radium, by the way? What's the mass of radium from the periodic table? Is it 226? Is it? This is probably stable. Okay. And Dylan, that goes back to your earlier comment about the masses not matching. This is how it would eventually decay to something more stable. Turn the page. Y'all got some room to write underneath the great big HE, yes?
Yep.
Okay. Draw an arrow. I'm going to tell you the end result. I'm going to tell you that we ended up with thorium-230 and an alpha particle. What must we have started out with? If we ended up with thorium-230 and an alpha particle, what must we have started out with? How did you figure that out? Okay, so I know it's element number 92, which is what? Is it uranium? Capital U, that one I know. Uranium what? 234? Okay. See how you can move kind of backwards and forwards? You do have to know the mass and the charge on an alpha particle. Oh, no, actually you don't. It's on your green sheet right in the middle. Give me 10 minutes. Beta decay. Beta decay occurs when a neutron breaks apart. Every so often, neutrons disintegrate. And they disintegrate into a proton and an electron. And a neutrino, but we're going to be ignoring that. Okay. What's the charge on a proton? What's the charge on any proton? Positive 1. What's the charge on any electron? Negative 1. That's why when you put them together, along with a neutron and some atomic glue, you get positive 1, negative 1, they cancel. You get a neutron. So neutrons are neutral because they're made up of a proton and an electron and some other stuff that we're not going to get into. Sometimes they decay, they break up. So when it breaks up, the proton stays inside the nucleus, but can electrons stay inside a nucleus? Where do electrons fit inside our atomic model? You guys know this. Where do electrons fit? the electron gets ejected from the nucleus, the proton stays inside the nucleus, and you get a new atom, a new element. So the electron is then emitted as a beta particle. So an electron shoots out from the nucleus. If we zoom in, here's what's happening. Somewhere inside the nucleus, one of the neutrons goes haywire. It splits up. It splits up into a proton, which has a positive charge, a beta particle, which is an electron, which has a negative charge, and an anti-neutrino. You don't need to know that, but I wouldn't be a nerd if I didn't tell you. Then what happens? Well, when this neutron breaks apart, Brady, the proton can stay inside the nucleus, but that electron gets ejected out as a beta particle. So as a result of beta decay, so antineutrino, you don't need to know, Jessica, but I'm a nerd, I got to tell you it's there. As a result of beta decay, the nucleus has one less neutron. But it has one extra what? What did the neutron break up into? Electron. Where'd the electron go? Out. So what was left behind? It's got one extra proton. And because the number of protons is what determines what kind of element you are, Hannah, it's just become a new element. It's moved up one on the periodic table. Turn the page. So as a picture, whoa. Okay, let's try this again. The projector just died. Let's do this. As a picture, it looks like this. Turn the page. And we're nearly done. Okay. Here's our element. What element are we talking about here? We're talking about polonium. Oscar, you going to make it, kiddo? Tough it through. Polonium, element number 84. Suddenly we have a beta decay, so we got one extra proton. So instead of element 84, we are now going to be element number 85. We've got one extra proton. What is element number 85? Is it actinium? I got to look. Astatine. Okay. What happened to your mass? How much mass did you have beforehand? How much mass do you have afterwards? Why? How much does an electron weigh? 0. Oh, what happened to your overall charge? You had a charge of 84 before. You got 85 plus minus 1. What's your overall charge still? 84. That's why you gain a proton. So, the atomic number increases by 1, and the mass number stays the same. Stays the same. These ones printed out properly, so we're just going to write over top of these. Let's see if we can figure these out. The only thing that didn't show up was the arrow. So you can add the little arrow like that. Dane, you asked, How do we know what they give off? I'm going to tell you what they give off. This particular element gave off a beta particle. So, first of all, Dane, my friend, can you tell me what was the mass of the original element?
Oh, it was 210.
210.
And then 81.
Originally, it was atomic number 81, so I don't need to call it mystery element X anymore. What is atomic number 81? Which one? Thallium, which is T, capital T, lowercase l. So in this reaction, Dylan, thallium gave off a beta particle because a neutron decayed into a proton, an electron, and an antineutrino, forget that. The electron goes outside the nucleus. The proton stays in the nucleus. You've just gained a proton. You've moved up one on the atomic table. Okay? Oh, by the way, this should be PB, and this should be PB. It's lead, not phosphorus. And there's the answer to what we just did. Turn the page. Let's try another one. Hopefully without a typo this time. All right. Again, the arrow didn't print. Sorry, guys. Again, the arrow didn't print. We're giving off a beta particle. How can I tell? Because it's got the symbol for a beta particle. My original mass was 210. What's the mass of the new element that we decayed into? It's got to be 210. My original atomic number and the original number of protons was 83. I just gained one. How do I know? Because that's a negative one. What's my new atomic number? What's my new number of protons? 84. What's my new element? What is atomic number 84? Polonium. In fact, if we did it right, it should be this, except the O didn't show up again either for some reason. So, bismuth, when a neutron decays, can decay into, if it gives off a beta particle, polonium. Like one more and we're done. This one, yep, and gamma rays are pretty short. Once again, the arrow didn't show up. We have, our result is bismuth with a mass of 214, 83 protons, and a beta particle. So what did we start out with? How many protons, or what was the atomic number that we started out with? 82. What was the mass that we started out with? 214. What was the element that we started out with? Lead. So radioactive lead can decay into bismuth. That's beta particles. Is that okay, Justine? Lots of talking, I know, sorry. We're nearly done. Gamma rays. The ones that created the Incredible Hulk. Well, if you believe that. The ones that can really do damage. When atoms decay by emitting alpha or beta particles to form new atoms, sometimes the nuclei of the new atom might still have too much energy to be stable. And Dylan, this also goes back to your earlier comment about the masses not matching. This is another way an element can be unstable. It can have not too much mass, but too much energy in the nucleus.
What's the B beta?
Yep. Would that not make sense? B for beta, A for alpha? And if we have an unstable nucleus, if it's got too much energy to be stable, it emits this as gamma rays. Gamma rays are energy rather than charged particles like alpha and beta. They have a mass of 0. They have a charge of 0. Sorry, the equation's really, really blurry, but what was your original mass? 60. What's your new mass if you give off a gamma particle? Still 60. What was your original atomic number? How many protons? Sarah, 28. What's your new number of protons? 28. Why? You've just given off some energy. Alpha particles are blocked by paper. Very easy to stop. In fact, they won't go through your skin. If I fire a beam of alpha particles at you, Brendan, you're fine. Even though it's radioactive, you're fine. Beta particles blocked by metal foil. Easy way to block beta particles. So if I give you one of those metallic suits that you sometimes see them wear for radiation, blocks it just fine. Concrete will block beta particles just fine. Gamma particles mostly blocked by lots of lead. They'll go through paper, they'll go through foil, they'll go through concrete. You need some thick lead to block them. And that's why for radiation they'll talk about, well, radioactive waste, they put it in big lead shielded bins. We'll finish this chart and then we are done this very lengthy lesson. I apologize it took so long. Ready? Let's summarize. What's the symbol for each of these? Okay. For alpha radiation, it's got a mass of 4, it's got a charge of 2 protons, and you can either use the alpha symbol, or because it's a helium nucleus, you can just write the helium symbol. Laura, is that on your green sheet? Is that symbol there on your green sheet?
Yeah.
Near the middle, yes?
Wait, the fish there?
Is the symbol for writing an alpha particle on your green sheet. Think in the middle there somewhere. There is a little.
No.
Yes, it is, isn't it?
Oh, yeah. No.
Yes. Yes?
Yes.
Yes. Whole point. You don't have to memorize. So somebody's saying, do I have to memorize this? Or do I have to write this down? It's on your green sheet. What's the symbol for beta radiation? Beta radiation is an electron. Symbol for that is it's got a mass of 0, charge of -1, and you can use the letter E for electron, or mass of 0, charge of -1, and you can use the funky beta symbol.
Can I go to the bathroom now?
2 more minutes and then yes. I know you've waited patiently. I apologize. Gamma radiation. There's the symbol for it. Gamma is energy. What's the mass of energy? 0. What's the charge on energy? 0. What's the composition? These are made up of alpha particles. These are made up of electrons or beta particles. Gamma is energy. Skip the description. Charge. Alpha particle has a charge of 2 positives. Why? It's 2 protons. Beta particle has a charge of 1 negative. Why? It's an electron. Charge and energy, 0. Relative penetrating power. Alpha particles can be blocked by paper. Beta particles blocked by metal foil. Gamma particles blocked by lots of lead. Blocked by lots of lead. This lesson took a little longer than I planned, so just hang on here. I wrote homework. Let me check page 297. Okay, I'm going to assign this for homework, and when I see you folks on Wednesday, I'll give you the worksheet that I mentioned here, and then we'll have a quiz probably on Friday on this stuff. So your homework, it's 5 questions at the bottom of page 297. It's the reading check. Thank you very much for your patience.